Welcome to Wagner Academy as we begin our look at Chapter 4. Chapter 4 is all about triangles. This lesson will start with some of the basic things about triangles, classifying triangles. Some new, perhaps review terminology. You may know what these terms are already, but if not, you're going to find out about them. Make sure you use those extra examples in your book for help with your assignment if you're one of my students. So let's get started by classifying triangles by their angles, and then we'll do classifying triangles by their sides. So we can have a triangle that looks like this. If we think about their angles, these are all acute angles. These are all less than 90 degrees. That is one type of triangle in terms of a triangle classified by angles, acute. And this one, you would have obtuse, because you have one obtuse angle right here. So this is an obtuse triangle. And then in this one, I want you to put a little box in the corner for me. That would signify that we have a right angle. Therefore, that is a right triangle. So acute, obtuse, and right triangles. And let's review, write down what makes these what they are. So this is acute because all three of these angles are all less than 90 degrees. So these are all angles, or this is one where all the angles are less than 90 degrees. All right, all angles are less than 90 degrees. And that's with all of them, not just one of them, because we're going to have at least two in any triangle that will be acute. We'll talk more about that in just a second. So obtuse, this means you have one angle that is obtuse. In other words, one angle greater than 90 degrees. And in this particular triangle, it's the one I'm pointing to here. This is the one that is clearly, at least by its looks, bigger than 90 degrees. And then this one would be the right angle in this one. So that you have one angle that is 90 degrees. So one angle is 90 in a right triangle. So here it was one that was greater, here it's one that is, and then in acute, all of them are less than 90. If you've got 90 degrees right here, or something that's bigger than 90 degrees right here, these two together would have to be adding up to 90 in a right triangle and adding up to less than 90 in an obtuse triangle. You have to have at least something degrees. You have to have at least 0.001 degrees, something really small. So no way these other two could be anything but acute here and here. And then classifying triangles by their sides. Yes, I like the Legend of Zelda games. I'm a fan. We're going to get to that one on this third triangle here. It's like going on an adventure. I love adventures. And Link going on the big adventure to rescue Zelda, save the world, etc. In a scalene triangle classified by its sides, it looks like none of these are congruent. So you have no congruent, I'll use my symbol to abbreviate that, no congruent sides in a scalene triangle. And this kind of triangle, this is isosceles. Why is it isosceles? I'm going to have you put these markings on here. I purposely left those out at first. You'd have to have markings here and here, or you'd have to have information about the two sides being equal to know that it's isosceles. So if I give you that information, now we can say this is isosceles. And make sure you spell that right there. That can be a tricky word to spell. Isosceles, at least two congruent sides. Some books will say, let me write congruent. Some books will say that it's exactly two congruent sides. So if your book or your teacher expects you to think of this as exactly two congruent sides, just be aware of that. Our book, and for the purposes of myself, my students, think of it as at least two congruent sides. So you could actually have three congruent sides. Then we would have a special kind of isosceles triangle known as an equilateral triangle. So this one is equilateral because all sides are congruent. So I'm going to put marks, same number of tick marks on all the sides. So here all sides are congruent. And time to nerd out a little bit here. Yes, the triforce is composed of 3 equilateral triangles in yellow, and then makes a equilateral triangle there in the center. 4 equilateral triangles total. Amazing. Okay. Next up, what goes here? Well, an equilateral triangle. This is something that's written as a little side note in the book, and I'm doing the same sort of thing here. An equilateral triangle, if we look at that, we can actually say that all the angles are equal as well. So we could call this what's called an equiangular. I've heard it called equiangular, but I'll probably say equiangular more often than not. So it's also an equiangular triangle when classified by its angles. And this is something we'll learn more about later, but something that's both equilateral and equiangular is actually called a regular polygon. So a regular triangle is an equilateral triangle. So example 1, classify each triangle by both its angles and sides. So this one, let's think about the angles first. I notice there's a right angle in this picture. So this would be right in terms of the angles. And then by the sides, I see markings here and here, meaning that this is isosceles. I don't know if it's equilateral. I don't have that information. And actually, I could prove that it's not, because you can't have an equiangular triangle here if you have a right triangle. So we could say right isosceles definitely would not be equilateral in this case. So right isosceles, that's a final answer. Let me box that in. On this one, you have an obtuse angle. That means it's an obtuse triangle when classified by its angles. And it looks like I don't have any markings on the sides. I don't have any information about the sides. And it appears they're all different. So unless you are given information, we would have to say it's scalene. I don't know if any of the sides are congruent, so I'm saying this is scalene. Doing it again. Boxing that in. Okay. And on this one, looks like we have all 3 sides the same. So by terms, or in terms of its angles, we just learned up here that equilateral is also going to be equiangular. So I could say equiangular. Let me write equiangular first. I'm getting ahead of myself there. It's equiangular, equilateral by angles and by sides respectively. There we go. There's the box. And then on this one, well, it looks like I don't have any obtuse angles here. These all appear to be acute, and this one and this one are the same. These are congruent to each other based on the information given in the picture. Since I don't have anything that would say that any of these angles are obtuse, I'm going by the appearances. On these ones, typically it's okay that you do that in terms of the angles to see if something's acute or obtuse. So this one, I think it's pretty clear that it's acute and isosceles, because you have at least 2 congruent sides. So acute, isosceles on this one. Moving on to a second example. So find the measure of x, y, and each side of equilateral triangle ORT if OR is 2x minus 8, RT is x plus 4, and OT is 3y plus 13. So you might look at that and say, well, I have no idea what's going on. It sure would help if I had a picture. Can you draw a picture? Sure, yeah. So I purposely left out a picture on this one because I want you to get in that habit of thinking, okay, can I draw a picture for this type of problem? Absolutely, you can for this one. So let's draw an equilateral triangle. Just do the best you can. It doesn't have to be a perfect equilateral triangle. I'll try to do the best I can. So this one, I'd say that looks pretty good right there. And now I can label the sides. It's equilateral triangle ORT. So I'm going to go with O right here. I'll go with R up here and T right here. You might be wondering what this is all about, so I'm going to get on my soapbox for a minute. This is ORT right here. This is ORT. Why is that ORT? What is ORT? ORT is leftover or wasted food. And in America, we have way too much ORT. This is a real word. I'm not just making that up. I used to work at a camp where we did the ORT report, where kids had to put their leftover wasted food in a bucket, and we weighed the bucket. And we would give them prizes at the end of the week if we had under a certain amount of ORT at the end of the week. There's people, children all over the world, malnourished, and we continue to throw food away like like it's nothing. So I just want you to be conscientious, a conscientious citizen of the world. Do what you can to help other people in our country and other countries, and don't waste your food, don't waste money like that. That could be helping other people instead. Okay, off my soapbox, back to the problem. ORT, equilateral triangle ORT, we have OR is 2x minus 8. Let's label that right here, 2x minus 8. RT is x plus 4, so I'll put that right here. And OT, 3y plus 13. And what else do we know about this triangle? Well, it's equilateral. That means I could put markings, tick marks, same number on each side. Based on that, we can say that OR, well, let's write that little note out. I think that would be helpful to look at later. So since it's equilateral, all sides are congruent. And based on that, now we could say, so OR equals RT. I'm going to start there because I noticed both of those have an X in them. If I started with OR and OT, or RT and OT, then I would have two variables with one equation. I don't like that. I want just one variable. So I want to say then that 2x minus 8 equals x plus 4. The distance from O to R is the same as the distance from R to T if it's equilateral. Now it's a basic algebra problem here. Subtract x from both sides, add 8 to both sides, 8's cancel, x's cancel. We are left with x. We don't have to divide by anything in this one. So x equals 4 plus 8, that'd be 12. This is part of our answer. Notice though it says solve for or find the measure of x, y, and each side of equilateral triangle ORT. So I've found x, now I'm going to try to find y. So this would be true, and to find y, we could use either OR equals OT, or we could say RT equals OT. Both of those statements would be true. I'm going to go with OR, and OR is 2x minus 8. OT is 3y plus 13. You might look at that and say, well, how can we possibly solve for y? I don't know. Wait, I do know x. That's right. Okay, here we go. Plug it in. So plug in x is 12. And now you can solve for y. So we have 24 here. 2 times 12 minus 8 would be 16. That would equal 3y plus 13. And then this one I purposely made to work out nicely. Could you have fractions? Could you have decimals in your answers? Sure. But this one we're not going to. We will have 3 equals 3y, meaning if you divide both sides by 3, that y equals 1. And so that's part 2 here. We found x, we found y. Now we're finding each side of the equilateral triangle. Oh, why not? I'll use my therefore symbol. And so therefore we could say OR, we know OR equals RT, and we know it also equals OT. So all this is true. And I'm going to plug in y into OT to see what OT equals, and then I know what the rest equal based on that. So I have 3 times 1 plus 13. So this number is coming from right there. So we plug in that in, and then we have, this is 3, and this is 3 plus 13, 16. If you plugged in 12 for x instead into either this or this, you would get 16 here, you would get 16 here. You can check your answer by doing that. Always a good idea. So these all equal 16. We found then each side of the equilateral triangle. And then let's move on to our final example. If you're struggling with math, keep trying. That's what I'm doing this year. Don't ever give up like the frog who is choking the bird as it's being eaten. Kind of like Finding Nemo, right? So example 3, find the measure of the sides of the triangle below. Then classify the triangle by its sides. So we had different ways to do this. We could use the distance formula if we wanted to. And we could say this is -4, -2. This is 1, 2, 3, 4, 5, 6, 2, and we could say this is -2, 1, 2, 3, 4, 5. So we could label it. We could label our x1s and y1s, plug it into the distance formula. That's one option. I prefer myself, when it's graphed, to use the Pythagorean theorem instead, so I'm going to do that here. If you want to do this problem using the distance formula, if you prefer that, and see if you get the same thing, be my guest. I see nothing wrong with that. I have no problems with that. So I'm going to draw in, I'm using my different color, so this stands out from what I have in the picture here. I'm drawing the right triangles here in the picture that will allow me to figure out, using Pythagorean theorem, what my side lengths are. So this is a right angle, this is a right angle, and this is a right angle. And let's label what those things equal. So this is 2 on this side. This is 1, 2, 3, 4, 5, 6, 7 on this side. So TR, I can use 2 squared plus 7 squared equals TR squared. On this one, I've got 1, 2, 3, 4, 5, 6, 7, 8. And then going this way, I have 3. And then on triangle, or on this triangle with RY as the hypotenuse, I've got 4 here, and then this length is 10 down here. So let's use the Pythagorean theorem 3 different times. If you're using the distance formula, you use the distance formula 3 different times to figure out the lengths of all these sides. And then we're going to classify it. So if we have any that are equal to each other, that's going to tell us something about what kind of triangle it is. So we've got TR, or RT, doesn't really matter which way you say that. We've got, though, 2 squared plus 7 squared, so leg squared plus leg squared, or you can think of it as a squared plus b squared, equals c squared hypotenuse squared, which we'll say is RT. You could also say TR. So this would be 4 plus 49 equals RT squared. That's 53 equals RT squared. So RT, you take the square root of both sides to get RT by itself. The length of RT, square roots cancel. Left with the square root of 53 equals RT. So that is one of the measures. This is one part of our answer. I'm going to box that in and do the same thing again for same idea, Pythagorean theorem, for this triangle here and this triangle here. So next up, I've got 3 squared plus 8 squared would equal ty squared. You could say yt squared if you wanted. This is 9 plus 64 equals ty squared. That would be 73 equals ty squared. Take the square root of both sides just like before. Square roots and square will cancel. And this is not a perfect square, so square root of 73, I'll leave it like that, equals ty. You could plug this into a calculator, you'd get a little less than 9 because the square root of 81 would equal 9. This one you should have 7 point something because the square root of 64 is 8 and the square root of 49 is 7. That's going to be in between there. And let's see, this last one we have ry. So I can say that 4 squared plus 10 squared equals ry squared. yr squared would work just as well. You've got 16 plus 100 equals ry squared. That's 116 equals ry squared. Take the square root of both sides once again. Taking the square root thrice. 3 times we did that. And I love that word, thrice. It just sounds cool. So ry equals the square root of 116. Square root of 121 would be 11. The square root of 100 would be 10. So that's a little closer to 11 than 10 if we were to round that off. Are any of these the same? Nope. If one of these pairs were the same, then we would have isosceles. If they were all the same, then we would have an equilateral triangle. But we're classifying by its sides. We're not finding anything about the angles right now, but just the sides. So classified by its sides, this would be a scalene triangle since all the side lengths are different. So let's write that down. That'll be our last thing here. So since all the lengths, you could also say the measures of the segments are different, And there's my symbol for triangle. So triangle tri is scalene. So don't ever give up. Keep trying. You got to keep practicing math to get better at it, just like any other thing that you have to work at to get better at. Make sure you help other people out when you have the chance. Don't waste your food. Classifying things was what this lesson was all about. Play some Zelda. It's a great game. Make sure you know these terms, and have a great day.